Hello friends, and welcome back to my channel. Today in mathematics, we're going to be looking at how to integrate trigonometric functions. I have this question here. It says integral of x sine x dx. To integrate it, what I need to do is to apply what we call integration by parts. And integration by part is giving us integral u dv over dx is dx is equal to u times v minus integral of v dx over v du over dx. So I'm going to use this formula. Okay, this is integration by part. So I'm going to use it to integrate this function. Now, in this case, I'm going to call x u. So I'm going to say let x be u. Then dv over dx be equal to sine x, because remember that this is sine x dx. You have to remember that this formula is actually derived from the product rule of differentiation. Okay, remember that integration is the inverse of differentiation. So now the next thing I need to do here is to find the derivative of u, that is differentiating u with respect to x. Remember the integration formula, which is differentiation formula rather, which is n(a)x exponent x minus 1. So I'm going to use this formula to differentiate, to find the derivative of u with respect to x. Now remember that the given variable here is x and its exponent is n in the formula. So here the exponent of x is actually 1. So that is the power of x here is 1. So when I put 1, when I replace n with 1, I'm going to have 1 minus 1, that is 0. And anything raised to the power of 0 in mathematics is 1. So differentiating this variable is going to give me 1. That is du over, this is u over dx, that is 1. That is the derivative of u with respect to x. Now I'll do the same here. Remember that this is dv over dx, meaning that this is actually a derivative of something. So I need to find the value of v, because v is given in the formula. And to find the value of v, I need to integrate sine x. Integrating sine x, that is to get v, I'm going to have, when I integrate sine x, I'm going to have minus cos x. It's very important to remember. Now I'm going to replace all these things in the formula. The value of u, the v over the x, and the u over the x. I'm going to replace these things with these values I got here. U is equal to x, the u over the x is 1, v is equal to minus cos x. Now I'm going to replace everything here in the formula. So applying that, I'll write integral x sine x dx is actually equal to, that is u is x, so I'm going to write x here, bracket, then v is minus cos x, I'm going to write minus cos x, and bracket close. Remember there is minus sign here, I'm going to put it, then integral, then v, what is v? Minus cos x, I'm going to put minus cos x here, cos x, then du over the x, this is du over the x is 1, so I'm going to write times, this dot is multiplication, times 1 dx. So now this is going to be equal to, so I'll bring out minus sign outside, it will be minus x cos x, minus minus is plus, because minus times minus is plus. I'm going to put plus here, then integral cos x dx. The next thing to do is to integrate cos x. Integrating cos x, I'm going to have sine x. So this is the same thing as minus x cos x plus sine x plus integration constant, as is arbitrary constant of integration. So if I rearrange this, I'm going to have sine This is equal the same thing as sine x minus x cos x plus constant of integration. So this becomes the answer. Now there's another question I would have loved to solve, but you can solve it and comment below. That question is x squared sine x plus, or rather the x, an integral. So integrating x squared sine x dx. The only difference between this and this, because this one has x square, but this one doesn't have square. It's very important. You can solve it and comment below.